In this video, I would like to discuss with you the inverse trig functions, and we'll start with the primary trig functions, inverse sine. The inverse trig functions will always return an angle to you, and that angle will either be in degrees mode or in radian mode based on the entered ratio. So I'm going to assume that all of my examples are going to be in degree mode. So I would like to calculate all of the angles in degrees, and my calculator is already set to degree mode. If you are working with radians, then just make sure that your calculator is set to radian mode. So we want the sine inverse of 0.552. What this is telling you is that if the trig ratio for sine of that angle of angle theta is equal to 0.552, what is the angle theta? So in this case we have that the sine inverse of 0.552 is equal to some particular angle, and they're saying if we have sine of theta is equal to 0.552, what is the angle theta? Well, the way we get the angle theta for the trig ratio of sine is using sine inverse. And the sine inverse functions are right above the sine function. So we've got sine and the inverse sine. So we'll have to enter in a second function, sine inverse, and we'll key in the ratio. The ratio is 0.552. And we press the enter in order to evaluate that. So the sine inverse of 0.552 returns an angle to us, and that tells us that the angle is 33.504 degrees. So theta is equal to 33.504 degrees, and that's in degree mode. So if I were to calculate the sine of 33.504 degrees, I would get a ratio of 0.552. That's what inverse sine means. So in the next example, we are asked to evaluate sine inverse of 0.9982. What we are asked here is, we're told that if the ratio for the sine is 0.9982, what is the angle equal to? So we're trying to find an angle that gives us the sine of that angle is 0.9982. Or in other words, what this really means is that sine of theta, sine of the angle, is equal to 0.9982. So we want to inverse sine that value. The ratio is 0.9982. We want the angle. So we're going to use second function, sine inverse, and we've got 0.9982 and hit the equal bar. And the angle is 86.5617 degrees. So the angle theta is equal to 86.5617 degrees. So what this really means is that sine of 86.5617 degrees will equal to 0.9982. In other words, that the sine of that angle will give me the ratio of 0.9982. That's what we mean by inverse trig. Let's calculate this next example. We want the cosinverse of the ratio negative 0.52. So remember that this will give us an angle. So we want the cosinverse of negative 0.52. So we're going to use second function, cosinverse, and the ratio is negative 0.52, so negative 0.52, and hit the equal bar. And the angle is 121.332 degrees. So the angle is equal to 121.332 degrees. So what this really means is that the cosine of 121.332 degrees should give me a ratio value of negative 0.52. So remember that with inverse trig functions, we are given the ratio, but we want the angle. And in this next example, we want the angle for which tan inverse is equal to negative 0.32. So we have the ratio of negative 0.32, and we want the angle that will give us the tangent of that angle, giving us negative 3.12. So we've got second function tan, or a second function tan inverse, and the ratio is negative 3.2. And I can press the equal button and I will get the angle now. So tan inverse of negative 3.2 is negative 72 degrees. So that's equal to negative 72.64597 and so on degrees. Remember that that's always in degree mode unless you are in radian mode. So this is given to us in degrees. So what this means is that tangent of negative 72.65 degrees is equal to negative 3.2, the ratio, negative 3.2. Now let's talk about inverse cosecant. Now remember that cosecant is the reciprocal of sine. So we have cosecant inverse of 1.2. Now there is no cosecant inverse on my calculator function, so I have to use the reciprocal function here. And I know that inverse cosecant is going to give me an angle. So that angle is theta. So what do we know? We know that cosecant, or CSC, of theta, cosecant of theta, is equal to 1.2. So in other words, if I have the angle, I know that the cosecant of the angle is equal to the ratio 1.2. So I need to get the angle. But cosecant is the reciprocal of sine. So I can rewrite this as 1 over sine of theta is equal to 1.2. And that's great because now I know that 1 over sine is equal to 1.2. So therefore, sine of theta is equal to 1 over 1.2. And so I'm going to use this to get the angle, because the angle theta will be sine inverse, the inverse sine of the reciprocal 1 over 1.2. And so now I'm going to use my calculator to obtain sine inverse. So it's second function sine inverse, and I'm going to use brackets now because I need to get the reciprocal of 1 over 1.2. So that's 1 divided by 1.2 and close it up. And now I will get the angle that I'm looking for. And that angle is 56.44 degrees. So that angle, theta, is equal to 56.44 degrees. And so what that means is that the cosecant inverse of that angle will give me a value of 1.2. Now let's talk about the inverse secant. We want to determine the secant inverse of 4.5, and the secant inverse of 4.5 is some angle. We don't know what that angle is. We're trying to figure it out. Well, what do we know about this? We know that the secant of that angle, secant of theta, is equal to the ratio of 4.5. So what do I know about the secant function? Secant is the reciprocal of the cosine function. So immediately change that to 1 over the cosine of that angle is equal to 4.5. So if the reciprocal of cosine is equal to 4.5, then the reciprocal of both of these will give us, well, cosine of theta over 1 will equal to 1 over 4.5. And so now I can solve this equation for the angle. So the angle theta will equal to the cos inverse of the reciprocal 1 over 4.5. And so now I'm going to use my calculator to determine the cos inverse of 1 over 4.5. So I'm going to use second function cos inverse, and the angle, or the ratio, is 1 by 4.5. And close it up. So cos inverse of this ratio will give me the angle, and the angle is 77.16 degrees. And so I can conclude this, that the angle is 77.16 degrees. So in other words, that the secant inverse of 4.5 will be an angle of 77.16 degrees. Let's do one more to make sure that we've covered all bases. And in this last example, I'd like you to calculate cotan inverse of negative 1.25. And so remember that the cotan inverse will always return an angle to me, and that angle will be theta. So what does this mean? This means that cotangent of that angle theta is equal to negative 1.25. 1.25. Now, what does cotangent mean? Cotangent is a reciprocal function, and so what I can say is that cotangent of theta can be replaced with its reciprocal of the primary function. And the reason why I have to replace it is because I don't have any cotangent functions on my calculator. I only have the primary functions, sine, cosine, and tangent. So I'm going to replace it with the inverse, or the reciprocal. Cotangent theta is 1 over tangent of theta, and that's equal to negative 1.25. And so with that information, now I can use the reciprocal of both of these, and so I can say the reciprocal of the left side is tangent of theta, and the reciprocal of the right side is equal to negative 1 over 1.25. And so tangent of theta is equal to negative 1 by 1.25. So what that means is that the angle is the inverse tan. So that's tan inverse of the reciprocal negative 1 over 1.25. So now I can go right to my calculator and calculate tan inverse. So using second function tan, so it's tan inverse, and the ratio is negative 1 by 1.25, and close it up. So if I have the ratio, I'd like to get the angle. So tan inverse of negative 1 by 1.25 is equal to an angle of negative 38.6598 degrees. So the angle theta is equal to negative 38.6598 degrees.